Welcome back. In the last video, we proved this theorem that tells us that to show that something is a subspace of a vector space, all we have to do is to show these three properties. That 0 is in the subset, that if you take two elements of the subset, their sum is in the subset, and if you take one element in the subset and a real number, then the scalar multiplication of k with w is also in the subset. All right, so we'll be using this theorem to prove that W, which is t times 1, 2, 3, 4, for all t in R, that will be a subset of V. All right, so we need to prove the three properties. All right, first, we need to look at the 0 of V. So in this case, V is E4, the Euclidean vector space of dimension 4. So that means vectors of dimension 4. And so our 0 is going to be 0, 0, 0, 0. All right, so we need to show that it is in W. And so we need to show that it could be written this way. And so I'm going to write it as 0 times 1, 2, 3, 4. So I have my t in R, so this is in W. All right, that's the first property. Second property, I need to take two elements of W and show that their sum is also in W. So I'm going to take W1, W2 in W. So they're in W. That means they can be written as t times 1, 2, 3, 4. I'm going to call it T1 and T2. For one specific T1, T2, I don't know them. Then if I add W1 plus W2, I'm going to get T1, 1, 2, 3, 4, plus T2, 1, 2, 3, 4, and I could write that as T1 plus T2, vector 1, 2, 3, 4. All right, so I have my new T, and so W1 plus W2 is in W. I could take T equals to T1 plus T2, and it would fit this definition. All right, so property 2 is true. Property 3, I need to make sure I can multiply any vector of W by a scalar and still stay inside W. So take W, actually let me put arrows here. They're vectors in this case. And so in general, I don't want to put arrows because I find it confusing when they're functions and things like that. But in this case, they are vectors. So feel free to place an arrow here. All right, so I'm going to take any element of W. I know I could write it that way, and I'm going to take K in R. I need to check whether KW, which is K times T 1, 2, 3, 4, I'm going to write it as KT 1, 2, 3, 4. Well, that is in W with, let's call it new K. Let's call it T prime equals KT. Yeah. All right, I proved property 1, I proved property 2, and I proved property 3. All three were right, and so I know that my W is a subspace of E4 by the last theorem we proved, so theorem 1.2.1. All right, so hopefully you see that this theorem will really save us some time. I was able to fit this example in half a page, while usually proving the 10 axioms would be 2 pages.